1. Using volumes, best method for sharing data. Description. Docker volumes are managed by Docker and stored outside the container's file system. They persist even after containers are removed. Volumes are the preferred method for sharing data between containers because they are portable and optimized for performance. Steps to share data using volumes. Step 1. Create a named volume. Docker volume create shared volume. This creates a persistent volume called shared volume. Step 2. Run the first container with a volume. Docker run d, name container 1 v shared volume /data alpine sleep 3600. This container mounts the shared volume at /data. Step 3. Run the second container with the same volume. Docker run d, name container 2 v shared volume /data alpine sleep 3600. Now both container 1 and container 2 share the /data directory. Step 4. Verify data sharing. Write a file in container 1. Docker exec container 1 sh echo hello from container 1 /data /shared txt. Read the file from container 2. Docker exec container 2 cat /data /shared txt. Output. Hello from container 1. Pros. Data persists after the container stops. Optimized for Docker performance. Can be backed up easily. Cons. Not as straightforward as bind mounts when accessing host files. 2. Using bind mounts, host file system sharing. Description. Bind mounts allow a container to access a specific directory on the host machine. Changes in the host directory are immediately visible in the container. Steps to share data using bind mounts. Step 1. Create a directory on the host. dir/home/user/share data. Step 2. Run the first container with a bind mount. Docker run d, name container 1 v/home/user/share data alpine sleep 3600. Step 3. Run the second container with the same mount. Docker run d, name container 2 v/home/user/share data alpine sleep 3600. Step 4. Verify data sharing. Write data in container 1. Docker exec container 1 sh echo hello from container 1 /data /shared txt. Read from container 2. Docker exec container 2 cat /data /shared txt. Pros. Easy to access host files inside a container. No need to create volumes manually. Cons. Not managed by Docker. Risk of breaking file paths. Less secure compared to volumes. 3. Using volumes from legacy method. Description. This allows a container to inherit volumes from another running container. This method is deprecated, and using named volumes is recommended instead. Steps to use volumes from. Step 1. Start the first container with a volume. Docker run d, name container 1 v/data alpine sleep 3600. Step 2. Start the second container using volumes from. Docker run d, name container 2 volumes from container 1 alpine sleep 3600. Step 3. Verify data sharing. Write in container 1. Docker exec container 1 sh echo hello /data /shared txt. Read in container 2. Docker exec container 2 cat /data /shared txt. Pros. Simple way to share data. Cons. Deprecated in favor of named volumes. Containers must be explicitly linked. 4. Using TMPFS mounts for temporary data. Description. TMPFS mounts store data in RAM, not on disk. Data is lost when the container stops. Best for temporary data sharing where performance is important. Steps to use TMPFS mounts. Step 1. Run a container with a tmpfs mount. Docker run d, name container1, tmpfs/data alpine sleep 3600. Step 2. Run another container with the same tmpfs mount. Docker run d, name container2, tmpfs/data alpine sleep 3600. Step 3. Verify data sharing. Write in container1. Docker exec container1 sh echo temporary data/data/temp txt. Read in container2. Docker exec container2 cat/data/temp txt.
Pros.
Very fast because it uses RAM. Prevents writing unnecessary data to disk.
Cons.
Data disappears when the container stops. 5. Using Docker networks for data transfer. Description. Instead of sharing files, containers can communicate over a network. This is useful for microservices where one container, e.g., a database, needs to communicate with another, e.g., an API /. Steps to enable container-to-container communication. Step 1. Create a Docker network. Docker network create my network. Step 2. Run a container on the network. Docker run d, name container1, network my network nginx. Step 3. Run another container on the same network. Docker run d, name container2, network my network alpine sleep 3600 /. Step 4. Access container1 from container2. Docker exec container2 get qo http://container1.
Pros.
Best for API-based data sharing, e.g., databases and microservices. No need to mount files manually.
Cons.
Not suitable for file-based sharing. Comparison of data sharing methods in Docker. 1. Volumes, persistent. Managed by Docker, ideal for databases, logs, and config files. Data persists even if the container is removed. 2. Bind mounts, persistent, host-dependent. Maps a host folder to a container, allowing real-time file sharing. Best for local development, but depends on the host system. 3. Volumes from, persistent, deprecated. Old method for sharing volumes between containers. Replaced by named volumes and not recommended for new projects. 4. tmpfs mounts, not persistent. Uses RAM instead of disk, making it very fast but temporary. Ideal for caching and ephemeral data that doesn't need to persist. 5. Docker network, not persistent. Data sent via APIs. Containers communicate via APIs instead of sharing files. Best for microservices and distributed applications. Conclusion. Use volumes for long-term data persistence. Use bind mounts if you need to share host files. Use tmpfs mounts for temporary, high-speed data sharing. Use Docker networks if you need API-based communication between containers. Don't forget to like, share, and subscribe the channel for such videos.